Well, hello and welcome to another DevNation Live. We are excited to have all of you guys here today. We have another great topic with another great presenter, Edson Yanaga, who's going to walk us through feature toggles and hypothesis-driven development. If you've not seen this topic before, it's going to be awesome. Edson is one of our best speakers here at Red Hat, and he's going to deep dive into this topic. So remember, use the Q&A tab or the chat tab to ask us questions. I'll try to respond in real time where I can, but we'll hold questions towards the end, and I'll verbally ask them of Edson when he's ready to go. Okay, when he's finished his formal presentation. We have about 30 minutes to spend together today, so feel free to chat us up in the chat tab. And Edson, it's time for you to get going.
Hello, always a pleasure to be here. So as Bert said, today we're gonna discuss a bit about feature toggles, and I have a challenge. I have a lot of demos to show, and I also have to try to speak slower than usual. So let me try to share my screen with you right now. All right. So today's subject is feature toggles and hypothesis-driven development. I'm Edson Yanaga. My Twitter handle is @Yanaga, just in case you want to follow me. I discuss a lot about DevOps, microservices, Java, software craftsmanship, and other subjects, interesting subjects, I hope. I'm also a Java champion and a Microsoft MVP, which I believe is a very nice combination. And since we're talking about feature toggles for hypothesis-driven development, of course, we have to discuss a bit about DevOps. And all of this discussion around DevOps and, of course, continuous delivery. You need a fully automated software deployment pipeline. You have all of your deployment problems already solved, so you can get to the third step, which I believe is to test your business hypothesis. But so far, everybody doing DevOps and continuous delivery, the main goal of trying to establish a continuous delivery pipeline was to try to reduce the bugs that we were deploying to production between each one of our releases. So if you're discussing this DevOps thing so far, the main goal of that was to reduce risk. We were deploying software releases with bugs into production. We were trying to reduce our batch size so we could reduce the amount of bugs that we had into production. From a business perspective, we wanted to reduce the risk. But now that we have solved the deployment problems, we can dig into the hypothesis-driven development. And just to give you a comparison on how we traditionally do deployment pipelines, traditional deployment pipelines, you always assume that the next version is better than the previous one. So if I'm developing release 1.0, then the next version, I'm performing some commits into my master branch. And I'm assuming that the next release, 2.0, will be better than the previous one. I'll have fewer bugs. All of my features will be better than the previous one. I'm also assuming that the features that I'm developing right now are the best fit for the business. And if I release 2.0 into production, when I'm developing 3.0, I'm always assuming too that 3.0 will be better than 2.0. And the analogy that I like to make with this traditional pipeline approach is that we are developing software as we were cooking, or as we had a food buffet as a business, because somebody, probably the owner of the business, or the chef, decides the dishes that are going to be cooked that day. You're just assuming that people will consume the dishes in the same amount. So maybe you don't know if people will eat more meat or will eat more vegetables. So you just have to cook like our pasta, or you have to cook an enough amount that will satisfy all of the users that are coming to your buffet today. And as you can imagine, some days you have a lot of vegetarian people going to a restaurant, so you have a lot of meat that is not sold, not consumed, or the opposite could happen too. You have some people that own like meat or steak and they don't consume the vegetables. So you're just wasting a lot of time, a lot of effort, a lot of resources developing food or cooking food that's not going to be useful into production. So the traditional pipeline approach is that We assume that these features are going to be useful into production, but we don't know for sure. So we have to spend a lot of time and effort developing these features, even though we don't know yet which are the results that we're going to have into production. And when we're thinking about hypothesis-driven development, we can, the analogy that I like to make is that instead of trying to cook the whole buffet with all the dishes that we want to present to our consumers in production, we're instead just picking small plates of each one of our features, and we just cook a small plate, we offer to our customer. The customer decides, well, I like this food, but maybe you could put a bit less of spices, or put a bit more salt, or I didn't like that at all. Because if the user enjoyed the food or the feature, well, you can spend more time producing more that same feature. But if the user just rejected the feature, well, I didn't like the feature, I'm not going to consume this feature at all. You just can stop cooking that feature of that dish at that moment, and you can invest in other kinds of foods or features that would be more useful to you. Okay, so when we're talking about hypothesis-driven development, I don't know what will be the outcome of the feature that I'm developing right now. That's why I need to test, to give the user just a simple taste of what might happen. So the user, in fact, the data that the user is providing me can tell me which feature I should be spending more resources on. So if you're talking about hypothesis-driven development, if you ever heard about A/B testing, well, A/B testing is certainly one of the ways that we can achieve hypothesis-driven development. And when we have like this kind of A/B testing, we have version 1.0, and I have two different business hypotheses saying, well, maybe if I implement my recommendation engine this way, I'll have more sales into production. Or maybe if I tweak my recommendation engine this other way, I might have better results. So you don't know for sure. And the best way for you to test your hypothesis is to deploy them into production. So maybe you have two hypotheses, recommendation A and recommendation B, and the data in production tells you that, well, recommendation engine B performs better into production. So that's the branch, that's the feature implementation that we should be choosing to keep moving forward into our software. Traditional way of trying to achieve hypothesis-driven development with A/B testing is trying to implement with feature branching. So feature branching and A/B testing are done like that. You just, since you don't know and you have the different trees of commits in your source code, you just implement your feature A in feature branch A, and you implement feature B on feature branch B. And later, you deploy both versions to production, and you monitor the behavior to test which hypothesis is performing better into production. And the traditional way of trying to, well, two different deployments into production, and you need to route the requests of your users to your two different deployments, is to use a smart router approach. And with that, you just you add an artifact on your deployment, which means your requests are going through this smart router, and this smart router has the logic to route the request between feature branch A and feature branch B. It looks simple, but it also assumes that you're going to have a fully automated software deployment pipeline for both feature A and feature B, and people will be developing these feature branches separately. Of course, we also have our dangers. We have some problems that become even worse the bigger the team that you have. So imagine, for example, that you have all of the best practices for continuous delivery. Your continuous integration tool is integrating your trunk or your master branch for every single commit that you're performing. And of course, if you're developing your feature branch A and your feature branch B, for every single commit, or maybe even hourly or daily, you're pulling the changes from the trunk or the master branch to your own feature branch, so you won't have like later integration problems. But what happens if, well, I'm developing both the trunk, feature branch A and feature branch B, and later I decide that, well, I tested both hypotheses into production, and I'm going to keep one of the versions, but On the meantime, some other team is also performing some A/B testing, and they're developing their other features separately. And they decided that their feature branch B should be merged into trunk. The problem with that is that you were performing continuous integration of your feature branch A against the trunk, and the team developing feature branch B also was performing continuous integration with the trunk. But when the team developing feature branch B decide to merge their changes into the trunk, on the next pull, on the next continuous integration cycle that you have in your feature branch A, you just received like 1,000 commits. Well, 1,000 too much, but maybe 100 commits from feature branch B that you were not continuous integrating. So you just had a huge conflict because these feature branches were so different apart that now you have to solve this huge problem. And with all of the teams that I've ever talked to, the problem with that is that when they have such a huge merge conflict problem, most of them just decided, well, it's practically impossible for us to solve this merge conflict. We're just going to copy paste the files that are important in our feature branch. We're gonna discard everything. We're gonna get the trunk again and just copy over the files that we think that are important to our feature branch, and just tweak the rest that should be implemented. You might be guessing it's not right, or it's not a nice approach for you to be developing software, copying, pasting things, and then copying over the changes of other teams, right? But that's what usually happens if you're developing A/B testing with different feature branches. You just, one of the purposes of DevOps and continuous delivery pipelines is to reduce the batch size between each one of your releases. But every time you create a separate development branch, you are creating a huge batch size on that branch, and all of that commits that are being put together in that separate branch, they're creating a huge batch size that is going to be integrated all at once at trunk. So you have like a batch size of 100 commits. All of these 100 commits are going to be merged in a single request when you decide to merge that into your trunk development. So many people get burned with this kind of feature branching approach and huge merging. So that's why we decided to develop another A/B testing approach, another hypothesis-driven development approach, which is to use feature toggles. And with feature toggles, we just do trunk-based development or master-based development. Everybody commits on trunk, but the features are not released all together on every single deployment. You just delegate to a feature toggle the moment that you're going to release this feature into production. So in the DevOps terminology, we're saying that with feature toggles, we're just uncoupling releases from deployment. And the most popular example that we have from uncoupling release from deployment was the Facebook Messenger approach, because Facebook didn't know if their backend would support the amount of requests that Facebook Messenger would send to their infrastructure. So they deployed the Facebook Messenger feature into production, but the users couldn't see that. But in the background, your Facebook page was sending random requests to your friends to the backend, so they could test if the backend would support the amount of requests. And on the release day, somebody inside Facebook just decided, well, let's flip this feature toggle so we can release the Facebook Messenger to the users. So now they can use that. But in fact, in practice, people have been shadow using that into production for many months before the release. So we deployed the feature much before it was released to production. And how can we do that with code? So today I'm going to show you two different demos. One, I'm going to show you the 2GoZ framework for feature toggles, and the other one, I'm going to show you the FF4J feature toggle framework. So let me just show you here the web pages. So ff4j.org is the web page for feature FF4J, and 2GoZ.org, the web page for 2GoZ. Since most of us are probably Java enterprise developers, I chose 2 different Java implementations. You have different implementations from different languages and platforms too. The only one that I used into production was FF4J, because at that time, 2 years ago, I compared both frameworks, and in my opinion, FF4J was more mature. But just in the past couple of months, many people have told me that they were using ToggleZ, and ToggleZ evolved a lot in the past few years. So I decided to give it a try. And in my 1 week testing of both frameworks, I can tell that, well, they are both comparable in terms of features. So now maybe it's a matter of choice, which one should you be using. So in the past, I only knew about people using FF4J in production, but now many people reported to me, at least 4 different teams in the past couple of months reported to me, oh, we're using ToggleZ successfully into production, and they gave me some reasons for choosing that. And I said, awesome, because it's very nice for us to have competition in this field, so we can each one of the frameworks can improve in their own pace, and with some competition, it helps us to push forward the different implementations. So I just created 2 different projects. The first one that I'm going to show you is the FF4J demo. Okay, and can you see my source code right now? Where can you confirm that? No? Just let me double check with the chat. Yes, awesome. Thank you very much. You're amazing. So you can see my source code right now. Here I have a Spring Boot application. If I want to deploy an FF4J application, I just have to add some beans. So basically, I'm using the simplest possible approach for configuring FF4J. I just create an FF4J.xml. And on this FF4J.xml, I declare here 2 feature toggles. I'm declaring feature hello, which is enabled by default, and I have a description which I'll be able to see in my administration panel. And I have a new recommendation engine feature toggle, which is not enabled by default, and I have this beautiful description. So how does it work? If I have here my hello controller, suppose I just inject my FF4J instance as a Spring Bean, and I just need to check here if FF4J.check and the name of the feature hello, if that's enabled, I return hello. But if it's not, I'm going to return Olá, which is Portuguese. I'm Brazilian, so I'm going to return that in Portuguese. So I just added this if in my source code, and now I want to run my application. So if I decide to run this application, I'll be able to see that in my browser. So application is starting up with my feature toggles enabled, and it's already running. Okay, and now let's see localhost 8080/hello. So hello, my feature toggle is enabled by default. So if I want to tweak how is it working, let me open the console, the FF4J console. And now I have here my feature panel. It's toggled as on by default. If I turn it off, then I can just go to my web page back, and now it's showing things in Portuguese. So it's very easy to implement the feature toggle feature with FF4J into production. Okay, but this I'm adding this kind of if statements in my code. Right now, maybe we can have a better approach for that. So in some cases, we want to have like a different algorithm implementation into my production source code. So I want to test. So I created an interface recommendation engine, which has one method, and I have a default recommendation engine here. So it just returns like a default recommendation engine, which is burger, hot dog, and milkshake, which is very appropriate since yesterday here in the US, it was 4th of July, and I can tell you that people consume a lot of this when we have holidays here in the US. And I implemented the recommendation controller, which basically injects for me a recommendation engine instance, and I just return as the list of strings from this recommendation. Okay, so if I go to this implementation into production right now, go to recommendation, I have this beautiful JSON recommendation, which are burger, hot dog, and milkshake. But how can we do that changing dynamically into production our source code? So basically in the recommendation controller, I'm going to say that, well, this method, I want to add a FF4J feature, and the name of the feature is new recommendation engine. Right, and now I'm going to provide on my application 2 different implementations of the recommendation engine interface. So I'm going to add like public improved recommendation engine, and it's going to return a new improved recommendation engine instance, and it's going to be a bin. For those Spring lovers here, you know that, well, since I'm providing 2 different implementations of the recommendation engine interface at runtime, Spring would complain because Spring wouldn't know which one to inject, since I have 2 different options. So I have to mark one of them as primary to be injected. Well, if I have a conflict, you're going to choose this one as a primary, and I have to restart my application because I changed the source code. So let's see how it behaves. So let's get back to the recommendation, hitting reload and still getting the burger, hot dog, and milkshake. So let's go back to the panel. And here I'm going to turn the new recommendation engine on. And let's see which is the recommendation. Steak, steak, and steak. And for those of that know me, well, that's my particular favorite recommendation, because for me, that's my favorite food. Okay, so that's how you flip different implementations using FF4J into production. The backend repository that I'm using to store my feature toggles using FF4J today is just an in-memory repository. So it means that every time I restart my application, I'm going to lose all my data. But of course, FF4J provides you a lot of different repository implementations. So you can store your implementations using Redis. You can store that using MongoDB. You can store that using any JCache implementation, which means you could use InfiniSpan. You could also use JDBC. So you have many different options for using your FF4J. And with FF4J, I think that the benefits that you have a very nice Spring integration, which at the moment, for the amount of knowledge that I have from both frameworks right now, I would say that the Spring integration, the Spring proxy integration, for me to be able to do this flip switching with FF4J is a bit more mature than to go Z, but both are very nice frameworks. Okay, so next demo that I want to show you is just let me stop this application. Now I want to show you how can you perform the same kind of thing using to go Z. So now let me switch my project. You can see even, let me show you my to-go-Z implementation. And I'm going to run to-go-Z. So the basic endpoint is basically the same. And and this one, I'm using Wildfly Swarm as the implementation. So basically what I can do, the nice thing about to-go-Z is that it has a very nice CDI implementation. So if CDI is your favorite implementation of dependency injection, maybe you want to give a try. I just create the configuration. Also is very simple. I just need to create here, I just added a to-go-Z dependencies on my own .xml, and I created a class that implements to-go-Z config. So I have here, it gives the class that is implementing my features. The state repository, I'm using a file-based implementation because I think it was cooler to show you right now. And I have a user provider, which provides me the users for authenticating the console. And if you go, what does this class mean? This in FF4J, I'm basically implementing, since I chose to use an in-memory repository, I needed to create ff4j.xml, and I had to declare my features there. But if I'm using to-go-Z, I can create an enum, And I can declare my enum implementations here. So I can say that, well, I'm going to have two different feature toggles, hello, and it's going to be labeled hello to be shown on my interface. And I also have World Cup teams. We're playing the World Cup right now. So I have a different feature toggle called World Cup teams. And you have to implement this method, which is the default implementation. So if you think about how we implement the feature toggles, maybe toggle Z, my particular taste is that I prefer to code to implement things using code as in Java. So for me, it's a win that I can use enums for my feature toggles. Okay? So basically, that's all that I need to do. And in my hello world endpoint, I just have to check here using code. Just say if my features.hello is active, my enum is returning is active on this method, return hello, or else return hola. So let's go to my endpoint here. And hello, it's returning hello because it's enabled by default. But now I'm going to open my toggle Z console. Toggle Z, localhost, toggle Z. So if I open my administration console, I can turn it off. So if I turn it off, I go back here to my localhost and it's returning hola because now it's returning in Portuguese. So it's very similar the way that we can use both of them, my administration panel. But since I'm using my file repository, toggle Z automatically changes into production. Features.properties. It already changes dynamically the values of my properties file here. So if I decide to change it but to enabled, it's going to show hello again. And if I go back here, hello equals to true. So you have a thing here. It's an in-memory repository. It's a file-based repository. If you had JDBC, it would work the same. Okay. But I will want to show you other things like how can I do to, let's create another endpoint. World Cup endpoint. So I decide here I want to return some kind of JSON. If I want to implement that, I can do just the same if like my features dot World Cup teams is active. Maybe I want to return World Cup favorites dot better favorites. Yeah, or else I can return. I don't have a best practice, but I assume that maybe you want to show your feature toggles using if-else statements. I think it should be clear for you to see how the flow of the code is behaving. So let's restart my application because I just added another feature toggle. And just in case you were wondering, does toggle Z provide me the same proxy feature that you can switch the things dynamically without adding the if statement? Yes, but as far as I can tell, it only works with Spring. And since I'm using Wildflower Swarm with Java EE, I couldn't find a similar implementation for CDI. But I guess, well, that's the tip. Somebody could be implementing that. Let's see how it behaves into production. So hello, it's still working. And if I go here to my endpoint World Cup, it says that, well, the favorites so far are Croatia, England, and Sweden. But if I just go back to my administration console and I enable my new features saying, well, let's have better favorites for now, I would say that, well, maybe the favorites right now should be Brazil, Brazil, and Brazil, which, by the way, is playing tomorrow afternoon. And that if you don't have a favorite team so far, I strongly suggest you to cheer for us, because I will. And that's what I wanted to show you for now. So I'll stop my screen sharing. And if we have any questions available, I'll be more than happy to answer them.
Back on the scene here. All right. So John had a great question for you, Edson. It was around the concept of what about performance of a given feature? So think in terms of an A/B test. If I am doing an A/B test between, red versus blue or, green versus black, whatever the two things I'm testing, Brazil versus, let's say, Germany, Brazil's still in the tournament, how do we measure the performance of one of those particular features?
You mean business performance or backend
the business performance? The The
business performance. Okay. Yeah, as I mentioned that very quickly in a slide in the beginning of the presentation, you need to monitor behavior. And traditional way for you to monitor your application, well, you're just monitoring CPU, memory, network, and these kind of things, which is our back-end statistics. You have to start sending your statistics to a monitoring platform, and these statistics needs to be kind of business statistics. So maybe if you have an online sales application, you're going to measure how much you're selling at this time of day during 1 week. You're going to measure that and compare to your baseline on the week before. If you normalize all of the other variables, you can compare the algorithm between one implementation and the other one.
Okay, and I would mention that for A/B testing in particular, there are a lot of great online resources that describe what statistics you need to capture to validate that you are doing it correctly and making sure that A versus B is being tested correctly. Another question that came up. Oh, sorry, go.
Please go.
I was going to say another question that came up was related to what about not Java? So all your demonstrations were in Java, which of course is a primary user base for people like you and myself. But what about Python or Node.js or .NET? We did find a website, featureflags.io, that seems to gather all the different toggle Z type things. But do you have any other insight into non-Java platforms for feature flags?
Well, no. Yeah, I don't. Unfortunately, my experience is like purely Java, and that's as I said, I used FF4G in the past, and I've been playing with TogoZ in the past week, so I could have a baseline, but I don't have knowledge. I know that people are using feature toggles in other languages and platforms too. I just can't recommend anyone because it's out of my knowledge.
Okay, one last question, and we're out of time, but Vicky asked a question that I think is good to kind of recap and kind of summarize everything here. What is the exact significance of this framework? And if you already have instrumentation frameworks in place? So if you're already capturing metrics, what is the real value this is on top of those metrics?
Okay, well, metrics are a requirement for you to be able to perform hypothesis-driven development. You're already measuring the performance of your business results into production. And now, as I said, you can switch your, maybe you want to develop a new version of your recommendation engine, but you're not sure if the new version will be better than the current one. Or maybe you have two different teams that will be implementing two new different approaches, but you don't know for sure which one will behave better in production. So you can implement both features and then flip them dynamically into production just to monitor the results. And one of the things that I wanted to complement in the first question is that you need to monitor for a long enough time so you can compare with a baseline. And you have to be sure that all of the other variables are the same. I have to tell a famous taxi app in Brazil, for example, they were performing A/B testing. So they released a new version of the application, and they realized that the number of rides that they were having at that day was much lower than they had in the previous week. So they said, what's happening right now? And they just realized that, whoa, Monday at this time last week was raining. So we had much more rides. So it's unfair to compare with the metrics that we're having right now. So you have to monitor a lot of things to make sure that all the variables are the same to have a meaningful result with comparing your feature toggles.
Okay. Well, I'm afraid we are out of time for today. The recording will be available to folks that are interested in it. I did add both of Edson's GitHub repos for the demos that he showed today to the chat, so you guys should have those already. But always feel free to email me if you have a question, have a need, and also have a future topic you'd like to see us discuss. I'm now working on the next round of August and September and October DevNation live sessions, so if you have an idea, feel free to reach out to me at burr@redhat.com, and I'll get that information back to you. Also, the recording will be available as soon as we have it. Thank you so much. Thank you, Edson.
Thank you. Thank you all.